In this presentation, I'm going to be explaining U-substitution. So basically, U-substitution is used to integrate composite functions, and a composite function is just a function with another function inside of it. So, like right here, cosine of 3x plus 5 would be a composite function because 3x plus 5 is a function and it's inside of this, of cosine of this, which is another function. And so you would be substituting u for the inner function, which is the one inside. So in this case it'd be 3x plus 5. And then you take the integral of the u value. So I'm just going to run through how to do it with this example. So first step is figuring out what u should equal, and in a fraction like this with two different functions, it would generally be the denominator set equal to u. But if it's not a fraction, like this example, u would just be inside the parentheses, whatever is inside. So in this case, u would be 3 plus cosine of x because that's in the denominator. And then after you find what u equals, you have to find the derivative of u, because you're going to want dx to be substituted for some value that's in terms of u, which would be du. So the derivative of 3 plus cosine of x is negative sine of x, and then you have to isolate dx. So you multiply by dx and divide by this, and you get dx equals negative du over sine of x because of this negative right here. And this is why u will generally be the denominator, because at the end of all of this, you're gonna want to have no x values left, just u. And so if sine of x is on the bottom of this fraction, then this is going to cancel out with the numerator here, and there won't be any x's left. So after that, we substitute everything back in, and we have 4 sine of x over u, and then negative du over sine of x. And here we can use the constant rule, so we can move this 4 and this negative 1 to the outside of the integral. And then after that we can cancel out these. And so we're left with negative 4 times the integral of 1 over u du. And here we can integrate this pretty easily. So the integral of 1 over u would be ln of u, and then we're going to have to keep this negative 4, so it just gets put there. And then since it's an indefinite integral, we're going to need the plus c. So the last step would be to plug in this original value back into u. So our final answer would be negative 4 times ln of 3 plus cosine of x plus c. And this would just be the final answer. So here I have a practice problem for you guys to do. It's similar to the last one because we have this fraction, but it's different in a couple ways. So just pause the video and do it, and then come back and I'll tell you the right answer and how to get it. Okay, so the correct answer to this problem would be D. 5 plus 3x squared to the power of negative 3 over negative 3 plus c. And I'm just going to walk you guys through how to do it really fast. So since we have a fraction, the denominator would be what we're going to want equal to u, but we don't want this to the power of 4 in there. We'd rather have what's inside of this function, which is just 5 plus 3x squared. So that would be our u value, and then we would find the derivative of that, which would be 6x, and then dx would be du over 6x. And from there we plug everything back in, so we have 6x over u to the 4, and then du over 6x, and the 6x's would cancel out, so we'd be left with 1 over u to the power of 4 du. And this is where I said it was different than the one before, because since u is being raised to the power of 4, this would not be equal to ln of u. So I rearranged this so it's u to the power of -4, and then from here we can just integrate it as normal. So I got u to the power of -3 over -3, because you add 1 to the exponent and then divide by it, and you have to remember the plus c. And then from there just plug in this back into the u value, and this would be the final answer. And you can see here that after we cancel out the 6x's, there are no more x values, just u, and that's the ultimate goal that you want before you integrate. So the last thing I'm going to explain is how you can tell if you have an integral that can't be solved with U-substitution. So right here I have sine of 5 plus 3x squared, and this is a composite function, so u would be on the inside, which would be 5 plus 3x squared, and the derivative of that would just be 6x. But when you plug this dx back in here, you're left with sine of u and then du over 6x. And because we still have an x value and there's nothing else you can substitute u for, this integral is not able to be solved with this method. I don't even know if it's actually able to be solved in the first place. I tested it on an online integral calculator, and it gave me a bunch of errors, but I mean, this works for pretty much anything. If you have x's left over, you can't solve it with this method. Yeah, that's all. U-substitution is not too hard once you get the hang of it, but it's a really big help.